Hello folks, Perry again. We're in the shop tonight, and tonight we're working on a GoPro mount. This is for a generic GoPro receiver. So basically what we have here is 3 1/4-20 tapped holes and a base. The purpose for this, and why I didn't spend $20 on a GoPro mount from the store, is we're going to be mounting it on a magnetic base so that we can stick it to things and get shots with the GoPro. Well, let me prep some stock and we'll get started. This is going to be pretty much an all milling job. Okay, so we have our raw stock here. It's a piece of 303 stainless. It's exactly 1 3/4 in diameter. It's been faced on one side and a 204 thousandths hole drilled through it to give us a center datum so that we can basically fixture off of that, and that is also going to be the center tapped hole. So one thing that's different about this drawing, how we're going to deviate, is these sides right here that you can see, they don't serve any purpose. They're pretty much vestigial, and if you were to buy a GoPro mount in the store, it would have flat sides. So what we're going to do actually is we're going to mill 2 sides parallel to create an orientation on this, because we want to grab this in a vise, and ultimately these 45-degree angles right here, I'm thinking I'm going to do those with a rotary table. So the first step is set this up in the vise like such, pretend my fingers are the vise, and then we'll mill a flat, and then we'll flip it upside down, mill another flat, and the flats will be 1.46 inches apart. Okay, let me fill you in on the strategy here. So on this machine we have a Meditaio digital quill readout. What we're going to do is bring it down, and we'll touch off to that. We'll reset our quill readout to 0, and then we'll feed down the half distance between 175 and 146. So what I've done is I've set this up on a 3/16 dowel pin just to create an arbitrary datum. Once we've milled this side flat, which we're going to take 145 thousandths off, probably in 2 or 3 passes. Once we've done that, we'll get a parallel, probably like that, and we'll put it under there, flip it over, and then we'll mill the other 145 thousandths off. So we're about 750 RPM. And we're roughly centered there. Unlock our table. I think, since we got to do 145, I think we'll go 70, 70, and 5. Okay, that's 71. And this is a cobalt rougher, so I'm not going to try to push it too hard. First cut, we're doing 140. And our last pass will be 5 thou. We'll throw a little oil on there for giggles. That should be sufficiently clear. Make sure our parallel doesn't have any chips on it. Okay, bring it over. Touch it off. 0. Same process. Bring it down 70. Up and down. Cut. So I know from the cutoff that this is concave, so what we'll do is we'll just kind of bring it down. We'll just do a quick touch off there, and then we'll just take 5 thousandths off. Okay, that's 4.5 right there. I think since we're changing tools, I'm gonna switch to a wider cutter to do a final finish pass. Okay. Okay, well, we got a flat surface. The finish, could be a lot better, but I'm not gonna beg. The center part's gonna be milled away anyway. You can tell just the gear train in this thing doesn't like it. The dog engagement in the high gear is chattering around. So our tallest feature in the center is 207 thousandths deep. So let's go 100. Oh, let's really make sure that the end mill's in there. He's happy. Check our slot depth just to make sure that we actually got 100th out there. Okay, we're 105. So let's come down. Let's go down to, like, say 190. Okay, we're at 190 there. We're at 207. Okay, so we got our depth. Now I'm going to change things up a little bit here. I'm going to switch out tools and I'm going to finish, well, I'm going to at least get the two holes dropped in, because our holes are 204 thousandths in diameter, but the rib in the center is only 150 thousandths. And with the drill bit going down in there on a surface that's narrower than the drill bit diameter, you could run into a problem where as the tip breaks through the sides of that rib, it could cause the bit to wander back and forth and orbit a bit, and I don't want to do that. I want those holes to be in good shape. So I'm going to swap out to a drill bit before we continue. So what we're going to do is we're going to touch off our DRO, our quill DRO, on the parallel at 0, and then we'll just keep watching it, make sure that we don't go below 0. So these holes, the centers on these holes are plus and minus 400 thousandths from the center. So I just dial my X to plus 400 and minus 400, and we should be good. Okay. There's our holes. We can tap those offline. So now I need to do 231.25. Yeah, right at 280. Okay, then we need to step over to 2838. We'll call that good. 2836. Yeah, we're within a thou. So now we need to go to the opposite side. 231. 2. So we were consistently about 4 thou deeper cut, or 4 thou low on the last one. So this is 272, 266, so we're a little bit, so we need to go another 8 thou. So let's go to 270. 280. Okay, now let's step it over to 2838. Let's measure that slot width. Yeah, we're 364, 365. So our next cut, we're going to keep everything the same, but we're going to be at 8262 on the Y. So okay, I'm pretty sure we've done all the roughing we can do. Yeah, we've done all that roughing. So I think what we'll do is a little corner rounding. So this is a corner rounder of really not very well known dimension. Let's bring you in a little closer. Okay. I really don't have any idea what this is. I just pulled it out of the box. But we'll just give it a whirl and see what happens. Now let's see about that undercut. So what we have right here is an undercut end mill. How I made this was I took a 4-flute high-speed steel 3/8 end mill. I chucked it up in the lathe and I used an angle grinder with a cutoff wheel to do most of the undercutting. Then I used a grooving tool, carbide, in the lathe running about 2000 RPM, and I profiled the backside of the cutter and the shoulder to get a nice sharp shoulder. So what we have here is it's about 106 thousandths wide is the groove that it'll cut, and it has just about 115, 120 thou of cut depth. So hopefully this will work for us, and we'll be able to get a nice undercut groove. So the groove has to be 190 thousandths wide, and this will cut about 106 at a time. First we're gonna get this in here nice and snug, and then we'll touch it off on the plate here, and we'll set our 0. So there's our 0. I think, let's see, let's bring it off. Yeah, we've got a little witness mark there. Let's bring this back on here. So our slot needs to be 190, and this is a 140. What's a 50 thou? Our slot's 190, about halfway deep, so I think what we'll do is we can get it to go almost full depth. Let's check that second cut. So now we're at the point where we want to mill a 10-degree angle on each of these faces right here. This isn't going to be really anything precise per se. What we're going to do is basically just mill it until we see that 10-degree angle converge with this undercut. And the way I set this up, I've got a sine bar right here. I've got a 100 thou gauge block under here sitting on top of some narrow parallels so that it's clamping at the top of the sine bar. On the opposite side I have a 186,000 or 187 thousandths stack of gauge blocks. So what that does is it gives me a 10-degree angle, and since I milled these flats here, if I have this at 10 degrees, this is at 10 degrees because we're just trying to be 10 degrees off of perpendicular to the center line axis of this part. So I've touched off the original 5/16 end mill to the bottom here, and we're just going to go and try to do this. I've got an 1/8 inch dowel pin right here clamping this part. I've tapped it down on the parallels, so we should be secure enough. Should converge with this cut right here. And let me blow all the chips off. We should have a nice 10-degree angle there. Let me bring you in close. Well, since the battery died on the other camera, let me bring you in close on that 10-degree angle using the handheld here. You can see right here what we did is we cut a 10-degree angle this way, and so the angle's cut this way, that's exaggerated, and what it does is it intersects this surface right here, and it provides a spot for the ears on the GoPro mount to hook behind. Well, here is the completed article, or finished article. One GoPro mount. I finished it by, well, once I filed all the burrs off and made everything smooth, I sandblasted it. This is just some heavy grit coal slag, And I thought, well, it being stainless steel, and I didn't feel like finishing out all the surfaces to a high gloss, that this was a good utilitarian finish. And this is the way it goes together. Now, there we go. Snaps in like that. Come on. It's being feisty. There it is. One GoPro mount with a 1/4-20 mount on the bottom of it, which I can easily just screw onto this magnet. Well, thanks for watching. Bye.